Hello dear students, this is your physics teacher Ashish Sharma, and in this video we will discuss resistances in series and parallel combination. So consider the three resistances R1, R2 and R3 which are connected in series. We must remember one thing, that when resistances are connected in series, they are connected like head of one is connected to tail of other and vice versa, and the voltage across the each resistance is represented by V1, V2 and V3. And also it is important to note here, if we consider this entire system as a single resistance, then the resistance of that single resistance is known as equivalent series resistance. So equivalent series resistance, if it is Rs, then according to Ohm's law, Rs must be equal to V by I, and V, which is the voltage across this combination, must be sum of the three voltages V1, V2 and V3 as they are connected in series. So we will start with the equation V is equal to V1 plus V2 plus V3. According to Ohm's law, as V1 is the voltage across R1 and I is the current flowing, so V1 must be equal to I into R1, and same for V2. V2 must be equal to I into R2 and V3 must be equal to I into R3. Putting the values IR1, IR2, IR3, taking I common, I and I will get cancelled, and Rs is equal to R1 plus R2 plus R3. So that is your formula for series combination. Now let us move to the parallel combination. In parallel combination, the resistances are connected such that all of their heads are tied together and all of their tails are tied together. Now considering this as a single identity, the equivalent resistance is known as Rp, that is equivalent resistance of parallel combination, and the voltage across each resistance will remain same in parallel combination, but the current which is entering from the battery in this combination must divide into three different currents depending on the numeric values of R1, R2 and R3. Let that current be I1, I2 and I3. By conservation of charge, we know that I must be equal to I1 plus I2 plus I3, because there is no other point from where current is going. If I current is entering, then I1, I2 and I3 must be equal to I. Now again applying Ohm's law on individual resistance, as each resistance has same voltage V across it, so we can write I1 is equal to V by R1, and similarly for R2 and R3, I2 is equal to V by R2 and I3 is equal to V by R3. Again taking common, V and V will get cancelled out, and we have the formula for parallel combination of resistances. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So it is very simple, like if you are having 2 ohm and 3 ohm and 6 ohm, then their equivalent resistance between points A and B will simply be RAB is equal to 2 plus 3, 5 plus 6, 11 ohm. And if we are having same resistances in parallel, then something very interesting takes place. Suppose it is 5 ohm, it is 5 ohm, it is 5 ohm, three resistances, they are connected in parallel. Then by the formula which we just have arrived, R parallel is equal to 5 by 3 ohm. You can solve it. So if the resistances are of equal values in their parallel combination, you just divide single value of resistance by the number of resistances. If it would have been 5 resistances of 5 ohm each, 5 resistances of 5 ohm each, this is 5 ohm, 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 then their parallel combination resistance between A and B, that is RAB, that will become 5 by 5, and that is 1 ohm. Okay, there are questions I'll share with you. which are very simple but confusing for students. Like, consider this arrangement: 1, 2 and 3. Three 3 ohm resistances, and a wire is connected like this and a wire is connected like this. So these resistances may appear you that they are connected in series, but in actual they are connected in parallel. As you can see, I can show you by color code. Let us take red color for head of one resistance and green color for tail of the resistances. So it is the tail of this is tail of this, and the tail of third resistance. So you can see here the tail of all the resistances are connected together, and head of all the resistances are connected together. So indeed it is a parallel combination, and the answer is RAB is equal to 1 ohm. So you need to spend time on understanding how, with the help of these wire connections, we can change their connection, which may appear in series but in actuality is in parallel. Or sometime you will be given a question simply like this: a ring is given having resistance R, a wire having resistance R is bent into a form of ring. What is the resistance between diametrically opposite points? So simply R by 2 and R by 2 are in parallel combination, and resistance between A and B will become R by 4 ohm as they are in parallel. Okay, so practice the numericals, and if you are having any doubt, you may ask me in comment section, and I'll try to make an answer video for you. Like always, thanks for watching.